So quite a few people have asked for a simultaneous equations video, and in this one we're just going to focus on elimination method. But first of all, let's just remind ourselves that simultaneous equations are having two equations with two unknowns. So we've got the x value, we've got the y value, and one equation on its own is not enough. We can't pin down one x value and one y value that satisfies this. In fact, there's an infinite number of values that will work for x and y for one of the equations, and an infinite number that will work for the second equation, but only one value of x and one value of y that will work for both equations at the same time. And this is what this example shows. Here we've got 3x minus y equals 5, and this line shows all the infinite number of possibilities anywhere on that line that you will get 5 using that x and y value and that expression. And here is x plus 2y equals 4, and every point on this line shows a combination of numbers, decimals, whole numbers, all of them, and that perfect combination of that x value and that y value, when you put it into x plus 2y, gives you 4. But what's the one value of x and the one value of y that works for x plus 2y equals 4 and for 3x minus y equals 5? Well, it's this value right here where the two cross over. That's the point, and this coordinate is 2 and 1. So the value of x being 2 and the value of 1 will make this equation happy and this equation happy with the same value of x and y, and that's the point of simultaneous equations. So if you're doing simultaneous equations on a graph, then you can just find that, draw them, or maybe they'll be drawn for you in the exam, and you just get that point and you just take it down to the x-axis, and in this case it's 2, and the y-axis, and in this case it's 1. Now that's all very well and good, but what about when we haven't got a diagram? We've got to do it algebraically. Well, absolutely fine. All we need to do is eliminate, hence elimination method. We just need to eliminate one of the variables by combining the two equations into one equation in such a way that these cancel out. So if we look at it, it's pretty obvious it is 2y we should be cancelling, because they're the same. They will cancel. If I cancel 5x and 3x, I'll be left with 2x. I won't get rid of them, so there's no point doing it. But 2y and 2y, they'll cancel each other out. Now they're both positive, so the way we're going to get rid of them is to subtract. And the way I remember it is if the signs are the same, you subtract. Bit of alliteration, can't go wrong. The signs are the same, they are the same. Signs are the same, subtract. So we're going to take away the entire equation from the other equation. And the key thing is to look at the signs of the thing that you're cancelling, and that dictates what you're doing for everything. If these were different signs, you wouldn't add this bit but take this bit and add this. If it's whatever you're cancelling, the signs are the same, which they are, we subtract. So everything gets subtracted. 5x take 3x is 2x. 2y take 2y disappears. That's the whole point. We get 0y. And that's why I sort of draw a big 0 around it. That's what I'm getting rid of. It goes away. 23 take 15 gives me 8, which gives me a value of x being 4. So I found the x coordinate. If I had got a diagram, I'd read it off and I'd read the value and it would be 4. How do I get the y value? Well, you could try and eliminate the x's, and we'll talk about how to do that when the numbers are different in a bit. But you don't need to. Once you know what x is, as long as you got that right, then you can just put that back in. Of course, there's no way to know if you got it right or not, other than just checking you're working carefully. So we have to assume we've got it right, put it back in. 3 times x plus 2 times y is 15. Well, 3 times x, 3 times 4 is 12. So we've got 12 plus 2y equals 15. Take the 12 from both sides, we get 2y equals 3. So y equals 1.5. And here we have the answers. X equals 4 as an answer, and y is 1.5 as an answer. And that's it, you're done. Now, sometimes you need to give your answer as a coordinate. So like they have here as a coordinate, so it'll be 4 and 1.5, but that's not particularly arduous. You just put the x number first and the y number second in a bracket with a comma. Easy peasy. Let's look at another example. So here, looks a little bit worse because of two things. First of all, there's minus signs all over the place, which we've got to be careful of. We've got to be just careful with our negative numeracy. But also, none of the numbers are the same. 3 and 2x, not the same. They're not going to cancel. 4 and 2, not going to cancel. But what I'm going to do is I'm going to change the second equation so that it does have the same coefficient as the coefficient in the first equation, and then they'll cancel. So how am I going to do that? Well, if I were going to the shop and buying some x's and some y's, and it costs a certain amount, if I go and buy twice that amount, it'll cost twice as much money. If I buy 3 times as much, it'll cost 3 times as much money, obviously. So what we can do is we can just scale this up. To get these to be the same, I've got minus 4y and I've got 2y. If I just times the whole of this equation by 2, then I'll end up with 4y and I can cancel them out. So I've still got my 3x minus 4y equals 11. And then I'm going to double everything here, so I get minus 4x plus 4y, and this equals minus 12. Now, this time, the signs of the thing we're cancelling, which again is y, but look, the signs this time are different numbers. So before, if the signs were the same, we subtracted. Well, we're not going to do that now. This time, the signs are different, so we're going to add. We just do the opposite. So we're going to add them together. Now be careful, because we're actually going to make a mistake with the negative signs if we're not careful. 3x add. Now some people like to put what they're doing in between, so we're adding them. So if you just write a plus in between, it helps you to remember and not to get confused with the minus signs. 3 add take away 4 is just the same as 3 take away 4, which is minus x. And minus 4 add plus 4 cancels out. Negative and positive, they cancel out. And so minus x equals 11 add minus 12, which is minus 1, which gives me x equals positive 1. We just divide by minus 1 or times both sides by minus 1. Doesn't matter how you do it. You can just think, well, if both sides are negative, then we can ignore the negative sign. It really doesn't matter how you think about that. We put the x is 1 back into one of the equations, and we may as well pick the one with the smallest number. So 2x plus 2y equals minus 6. So minus 2 times 1 is minus 2, plus 2y equals minus 6. Add 2 to both sides, we get 2y equals minus 4. So y equals minus 2. We divide both sides by the 2. So what do we do here? We did the opposite of taking 2. We added it to both sides. Minus 6 add 2 is minus 4. And then we divided by the 2. And minus 4 divided by 2 is minus 2. Let's give our answer as a coordinate just for the fun of it. And there we have it. You've solved the simultaneous equations. You found the x value and the y value that satisfy both equations at the same time. Okay, let's have one more example and then I'll give you some to do. In this one, well, I'll just let you have a look at it. Have you spotted the nastiness that they've put into this one? Okay, well, what they've done, you see, is they've not lined up the x's and the y's. They've crossed them over, probably because of this negative and not wanting. In this one, we had just a minus in the front, but we don't like that. That's not perfect. So they've just switched it around, so it looks a bit neater, but now look, they're not lined up, so be very careful. Okay, but they are both the same value of x, so we don't need to scale these ones up. Okay, but I'm going to rewrite them so they're lined up. So we've got 4x plus y equals 10. And I've got minus 4x plus 5y equals 26. So the 5y is still positive, and the 4x is still negative. I've just switched them over. And look, here I've got x is the same. And previously we did one where the y's were the same, and again the y's were the same. It doesn't have to be. It can be the x's. It's whichever one is the same, or whichever one you make to be the same. So in this case, they're both the 4x. One's positive, one's negative. The signs are the same, you subtract, but they're not the same. They're different. So we're going to add them up. So we're going to put little plus signs in between, so I don't forget that we're adding and do something crazy. Actually, there's no more negative signs, so I shouldn't really make a mistake, but it doesn't hurt to do these things to make sure you're absolutely clear, because you don't want to lose the marks in your GCSE exam. 4x plus minus 4x disappears. That's the point. That's why big fat 0 round the whole lot. Y plus 5y gives me 6y. And add them together and we get 36. 10 plus 26. Divide by 6 and you get that y equals 6. Put that back into, I think I prefer the one like this, with just a single y. So we get 4x plus 6 equals 10. Take away 6 from both sides. 4x equals 4. X equals 1. So we've got our two answers. X is 1 and y is 6. And if you like your coordinates, then we'll pop them in. Pop them in a bracket to make a coordinate. The key thing here is for you to find which letter has the same number, has the same coefficient, same number in front of it. 4 and 4. Doesn't matter about the minus and positive signs, okay, as long as the value is the same, so in this case both 4s, then you just look at how we cancel these together, okay. If they're different signs, we add them, because if the signs are the same, you subtract. So if the signs are not the same, then you don't subtract, you do the opposite, you add. Now, you just want to be a little bit careful with those negative signs, especially if you're taking negative signs. Remember that taking negative signs is going to add instead of actually taking. Okay, so we work out which one has the same, and if neither have the same, if it's 4 and 1 and 3 and 5, we're going to pick one to scale up. So what we did in this question, if you remember, was we said, well, they're not the same, so we times the whole equation by 2 so that they would be the same. So you scale them up so that you've got something the same, draw a big fat 0 around it because that's what it's going to become, and then work out what's left with everything else. And you should be able to solve that then and get one of your values. That goes back in, and you've got to work out what the other value must be. Now that you know what y is, you should be able to find x. Once you know what x is, you can find out the y value that suits, because there's only one of them, because it's a straight line graph if you were to graph it. Okay, so let's show you these. These are some questions for you to have a go at. Let me just give you some advice. There's a lot of negative signs here, so be very, very careful. And if you are subtracting, then I would write a little negative sign to remind you that it's -2 minus -5, and that does make a difference. You're not going to do that because look, 2 and 5, 3 and 2. You need to scale one up anyway. And it might be you scale up the x's and cancel them. It might be you scale up the y and cancel them. It doesn't matter as long as you get one or the other. The other's still lots of negative signs, so be very careful as you add and subtract them. Again, this one's all right because they've both got the same thing. Look, -3y in both things, so we can just get on and eliminate. Here, 8 and 4, 3 and 1, you can't eliminate yet. You really need to scale up one of them, either scale this by 2 and get both the 8x's, or scale it up by 3 and get them both -3x's. It doesn't matter which way you do it, as long as there is a letter in each equation with the same coefficient, the same number in front of it, then you can combine the two and eliminate that variable, leading the way to solve the equation for the other variable. Anyway, I digress. I've got 3 questions here. Give them a good go, and I'll make another video with the answers for you. Ta-ra for now.